Video number 72, compound interest. We're going to compound interest annually, which means we're going to have the interest paid once per year. Let's take a look at compound interest example to explain the formula. Formula's down here, let's work to it. We got $1,000 at 10% interest. Well, after 1 year, we're going to have $1,000 plus 10% of 1,000. So we're going to do 0.10 times 10. So this is your principal, this is your interest. So we're going to make $100 in interest, so therefore we're going to have $1,100 after 1 year. After 2 years, we're going to do 10% of 1,100, because after the first year you're going to have 1,100, so now we're going to earn 10% of that. That's going to give us an additional 110. So rather than just earning $100 every year, we're going to earn more than 100 each year. That's the idea of compound interest. We're earning interest on interest. Okay, so we're earning 110 here plus the 1,100, so now we got 1,210. After 3 years, we're going to have 1,210 in our account plus 10% of 1,210 at the end of the third year. That's going to give us $121 in interest. This is called accrued interest. All right, so there's our 1,331. So as you see here, we're going to be going up in not a linear, but in an exponential form. So our rate would be growing at this kind of rate, like this. That's why it's that's why this is in the exponential section of your chapters. Okay, any amount after 1 year would be the principal plus the principal times the interest rate. Now, if you factor out a p, factor out the principal, you end up with principal times 1 plus r to the first power. Okay, now let's take a look 2 years. Well, the first year, you're going to have the principal times 1 plus r, because we just figured that out over here. Then the second year, what's going to happen? You're going to take the interest rate times what you earned in the first year. Now, if you understand factoring by grouping, we're going to factor out this, p times 1 plus r. So we're going to have left over an extra r here, okay? So if you factor out p times 1 plus r, you're going to be left with 1 plus r. That's why we put this here, which gives us p times 1 plus r to the second power. So after what? 2 years, you're going to have a second power. After 1 year, you're going to have a first power. So therefore, after t amount of years, any amount, you're going to use t for the exponent. So this explains the formula now. All right. Okay, so you deposit $4,000 in an account that's paying 9% compounded annually. How much will we have after 5 years? There's our formula. There's our principal, $4,000 times 1 plus 0.09. You see, 9% equals 9 out of 100. That's why we put the 9 in the 100ths position. So 1.09 to the fifth power. Rounding to the nearest dollar, it's 61.54. Rounding to the nearest penny, it's 61.54.50. And this should be approximately, because we did round off. All right, next one. You want to have $500,000 in retirement, in a retirement account after 25 years from now, okay? What amount should we deposit today if we want to get an annual interest rate, if we can get an annual interest rate of 8%? Well, we use the same formula. Our goal is $500,000, okay? This time we're solving for the principal amount invested. So we have 1.08, 1 plus 0.08 to the 25th power, 25 years. We're going to divide both sides by 1.08 to the 25th power, and we're going to get about $73,000. And now here's the idea here. If you want to get the exact amount, if you try this in the calculator, most people would think to round down. But we're going to use the rounding up principle because we want to make sure we have at least the $500,000. So we're not going to use 95 cents. We're going to use 96 cents. So check in the calculator on this and you'll see what I'm talking about. You're going to round up no matter what whenever you're trying to calculate the future value by finding out what we should use today. Okay? Any questions or concerns, send me an email. And of course, good times.